This is the I Promise project. The Akronauts rocket design team has been developing this project over the last 2 years as the first flown two-stage rocket of the team. After 3 failed test flights of the project, which included 2 launches with no sustainer ignition and 1 full-scale launch with a malfunctioning motor, the team is happy to say that the last flight was a successful one. To explain the systems that make up the launch vehicle, we'll start at the bottom with the fins.
Our rocket is equipped with 6 clipped delta aluminum fins. We chose to use aluminum this year over fiberglass in order to improve stability and maintain the structural integrity of our rocket. We also performed fin flutter calculations to help us determine the best dimensions for our fins while maintaining a factor of safety of at least 2. Our fins are then cut at Wardjet in Talmadge, Ohio on a water pressure cutter with a water pressure of 12,000 pounds per square inch. To assemble our fins to our rocket, we use an L bracket retention system. The retention rings are screwed to the airframe and the fins are able to be assembled to the rocket using L brackets.
From the first to the second flight, we increased the size of the booster fins for increased stability. Speaking of the booster, we can elaborate on that section next.
One of the most pivotal components on our rocket is the booster motor. For this, we have selected a commercial off-the-shelf Cicerone K1440. This motor provides us with a thrust-to-weight ratio of 8:1, and it produces a max thrust of 410 pounds. For our stage separation system, we'll be using Perfect Flight Mini Timer 4s, which will register when our motor has burned out and will then subsequently separate the stages based on black powder charges.
With successful stage separation and second stage ignition, we can now talk about the sustainer.
Yeah, so our sustainer is really cool. It's equipped with a K260 motor, which has a max thrust of about 98 pounds, which is really cool because it meets our thrust away requirements according to Spaceport. Above that, we also have a tilt bay equipped with an easy mega tiltometer that ignites our second stage motor utilizing 3 parameters: tilt angle from vertical, time from launch, and altitude from launch, or like a minimum altitude required. Also, around the motor, we have a really cool fin retention concept utilizing steel L brackets to retain in our fins, utilizing 2 ⅛ screws, which is plenty strong enough to hold our fins throughout flight. This stage flew successfully to 9,780 feet on May 1st, 2021. And was a completely successful flight, completely successful recovery. So we're really excited to show this off. You'll hear a lot more about a lot of, some of the things I've mentioned, like our telemetry unit from our avionics guys. So, yeah.
Next, we'll talk about the recovery system of our rocket, which was a vital part of retrieving the launch vehicle with very minimal damage and allowed us to refly and achieve a successful launch.
The 2-stage Subscale launch. This was a really challenging launch for us. We faced a lot of problems, especially early on, with the black powder damage on the parachutes. In an early launch in March, we ended up burning through one of our main parachutes. So we went back and we completely redesigned the black powder protection bags, giving them a new, sleeker design to help save space, extra padding protection between the bag and the parachute, and reinforcing them with duct tape to keep the black powder out. We also had to completely remake a parachute from scratch to replace the main that got destroyed. So the team came together and we ended up making a new parachute in just 5 days, which was absolutely incredible. So I was really proud of the team, and it was amazing to be a part of that. Launch day was beautifully orchestrated. We were able to get the rocket up and that second stage ignition, which was incredible because we've been trying for that for about several months now. So getting to see that was a really big deal, and the energy on the ground was amazing. Everyone was shouting. It was really exciting. And we had a perfect recovery, which is absolutely amazing, and it was really exciting to get to be a part of probably one of my favorite memories with the Akronauts. So, go Zips.
Finally, the nose cone carried our payload, a radio telemetry system that collected data through ascent and descent of the flight vehicle.
So housed inside of our nose cone is our radio telemetry system, or RTS. RTS is a student-designed avionics system that we use to get all kinds of cool live data. We get pressure, temperature, altitude, we get orientation data with an IMU, and we get all of that live transmitted from the rocket to a ground station via a radio modem.
As we grow our team and embark on new and increasingly technical projects, the team's mission is focused around continued dedication to student development and achievement for success.